Okay, today I'd like to talk about prime factorization. There's many ways to do it, but first of all, let's talk about what prime numbers are, composite numbers, and what factors themselves are. Well, prime numbers are numbers that have exactly two factors, 1 and itself. So the only way you can multiply and make a prime number is to multiply 1 times that number itself. A composite number are numbers that have more than two factors. Okay, so all numbers are going to have 1 times itself. But if you can find any other way to multiply and make that number, say 6, I can do 1 times 6, but I can also do 2 times 3. So it has more than two factors, so 6 is a composite number. And just remember, when I'm talking about factors, I'm talking about the numbers multiplied together to make a product. Okay, so let's just take a look at prime factorization. One method is the factor tree. So I think you'll remember this once we get started going through it. So let's just prime factor 72. Well, I'm going to start out with just basic math fact. 9 times 8 is 72. And then I'm going to check to see if either one of these numbers are prime. Well, 9 is not prime because I can do 3 times 3. 8 is not prime because I can do 2 times 4. Now if I check what's on the end of each one of these branches, 3 is a prime number, so I can't go any further here. 2 is a prime number, and 2 is unique because it's the only even prime number. And knowing that, 4 is even, but 2 is the only even prime, so I know that I can keep going with 4. So 4 is 2 times 2. So if I look at the end of all these branches, I see that the prime factors of 72 are 3 times 3 times 2 times 2 times 2. So I can write the prime factorization of 72 as 2 times 2 times 2 times 3 times 3, or if allowed, I can write it using exponents, which would be 2 to the third power times 3 to the second power. Another method we call the cake method, and we're basically dividing up, and we can only divide by prime numbers. So I always like to see if it's even. I'm going to start with the smallest prime number, which is 2. So I'm going to divide this by 2. Well, 52 divided by 2 is 27. Well, 2 won't go into 27, so I'm going to check the next prime number, which is 3. Will 3 go into 27? Yes, it will. 3 goes into 27 9 times. Well, will 3 go into 9 again? Absolutely. So I'm going to take it into 3. 3 goes into 9 3 times. My top number here now is a prime number, so I know that I cannot go any further. So the prime factorization of 54 would be 2 times 3 times 3 times 3, or I can use exponents and say that it is 2 times 3 to the third power. Let's take a look at one other thing that we might run into today, and that's prime factoring an expression that has variables in it. Well, let's look at the coefficient part first, and let's just go ahead and prime factor the coefficient like we have been previously. So I'm looking for two factors when I multiply together make 88. Well, the obvious one is 11 times 8. Well, 11 is a prime number because the only way I can make it is 1 times 11. So that's the end of this branch. Over here, I know that 2 goes into 8, so I can say that 2 times 4 is 8. 2 is a prime number, so this branch ends. 4 is not prime, so I go ahead and factor it. Well, 2 times 2 equals 4. So now that I look at this, I have 2 times 2 times 2 times 11 is the prime factorization of the coefficient. And then the variables, we just take them and write them in expanded form. So x to the second, we go ahead and write as x times x. For y, since there's only one y, we'd put times y. For z to the third, we would go ahead and expand it and say times z times z times z. when we prime factor an expression with variables in it, we usually leave it just in expanded form and don't use any exponents. So, well, I hope this helps a little bit. And as always, if you need help, be sure to reach out.